So let's take a look at some of the features of this quadratic. Recall that the y-intercept is the point 0, y. It crosses the y-axis when x is 0. So to find the y-intercept for this quadratic, we're simply going to plug in 0 for x. So if I do that, I'm going to end up with negative 2 times 0 squared plus 8 times 0 plus 1. Well, anything times 0 is 0, so that's going to go away, and that's going to go away. And we're going to end up with just this last number here. So the y-intercept is the point 0, 1. Now recall, quadratic that looks like this opens up. A quadratic that looks like this opens down. And which way is entirely dependent upon the leading coefficient a. If the leading coefficient is negative, it opens down. If the leading coefficient is positive, it opens up. So what do we have here? Well, a is negative, and that tells me that this is going to open down. Now, to find the axis of symmetry, we first need to find the x-coordinate of the axis of symmetry. Or not the coordinate, I mean the x value. So we have the axis of symmetry is x equals negative b over 2a. Well, here b is 8. So negative 8 over 2 times a. Well, a is negative 2. So negative 8 divided by 2 times negative 2 is negative 4. So negative 8 divided by negative 4 is positive 2. Remember, the axis of symmetry is an equation. It's a line. It's a vertical line. So the axis of symmetry is x equals 2. To get the vertex, I simply need to plug in this value. So the vertex is the point 2 something. Now to get this something, we need to substitute 2 in for x. So the y value is negative 2 times 2 squared plus 8 times 2 plus 1. The equation? Yes, it is. Okay, that means if I do this calculation, we're going to get the y value 9. So the vertex is the point 2, 9. So the maximum or minimum. So recall, if a quadratic opens up, this is the minimum. If the quadratic opens down, this is a maximum. Our quadratic opens up, or I'm sorry, opens down. Our quadratic opens down. Okay, so since our quadratic opens down, we have a maximum. And that maximum is just the vertex, which is 2, 9. Now lastly, let's write this in vertex form. Now recall, vertex form is y equals a times x minus h squared plus k, where h and k are the vertex. All right, so y equals, well, what is a? A was the leading coefficient, negative 2. So y equals negative 2 times x. Well, what was the x coordinate of our vertex? It was 2. And remember, we do the opposite. So this is going to be minus 2 squared And k is the y-coordinate of our vertex. So this is the equation in vertex form. Okay, so now let's identify some of these features again. First, we need to find the axis of symmetry. So x equals negative b over 2a, which is negative 12 over 2a. Negative 12 divided by 4 is negative 3. So the axis of symmetry is x equals negative 3. Okay, let's find the vertex next. Well, the vertex has an x-coordinate of negative 3, which we already found. To find the y-coordinate, we're just going to plug in negative 3 for x. So 2 times x squared, 2 times x squared, plus 12x plus 2. So the y-coordinate is negative 16. So we have a vertex at negative 3, negative 16. Okay, so we have the vertex, we have the axis of symmetry. To find the y-intercept, well, that's the point 0 something. Well, if x is 0, 2 times this is 0, x 12 times this is 0, so these both go away. And so this right here is our y-intercept. So 0, 2 is the y-intercept. All right, does this have a maximum or a minimum? Well, we need to look at the leading coefficient. Does our quadratic look like this or like this? Well, since this leading coefficient is positive, it's going to look like this. So since it opens up, that means we have a minimum. So the minimum here is just the vertex, which we found to be negative 3, negative 16. And lastly, let's put it in vertex form. So vertex form is y equals a, which is 2 for our quadratic, times x. Well, this one went left 3, which means this is going to be plus 3. This went down 16, so we're going to have minus 16 on the outside. So that is a vertex form. Okay, well, this one's already in vertex form. So the vertex is simply the point negative 1, because this went left 1, and since there's nothing out here, up or down, this hasn't moved up or down. So the vertex is negative 1, 0. Okay, well, the axis of symmetry is a vertical line that goes through the vertex. So the axis of symmetry is the line x equals, and it goes through the x coordinate. Okay, what's the y-intercept? Well, recall the y-intercept is when x is 0. So if x is 0, we need to find f of 0, which is negative 3 times 0 plus 1 squared, and that's it. Well, 0 plus 1 is 1. 1 squared is 2. I'm sorry, 1 squared is 1. And 1 times negative 3 is negative 3. So here's the y-intercept. Okay, so we need to know, does this have a max or a min? Well, does our quadratic look like this? Or does it look like this? Well, the leading coefficient here, a, is negative, which means our quadratic opens down. So here's our maximum. So our maximum is just the vertex, which is the point -1, 0. Okay, now the fun part. Let's put it in standard form. Well, to put it in standard form, I'm going to need a little extra room. This square means we're multiplying this by itself. So this is equal to -3 times x plus 1 times x plus 1. Okay, x times x is x squared. X times 1 is plus x. 1 times x is plus x. And 1 times 1 is plus 1. Now that is just these two parentheses multiplied together. We still have this -3 out in front. So let's combine some like terms. Okay, -3 times x squared. X plus x is 2x. Now I can simply distribute this -3 across all three terms. And so we end up with y equals -3x squared. -3 times 2x is -6x. And -3 times 1 is -3. So this is standard form. So we'll just take this whole thing here. And we'll move it all the way up here at the beginning of our problem. So here we have standard form. Okay. This one is very similar to the last one because it's already in vertex form. So the vertex is the point, well, this went right to. This is negative, which is the opposite because it's inside. So this is the point 2, 5, because this went up 5 and right 2. So here's our vertex. Now the axis of symmetry is just a vertical line that goes through the vertex. And our x-coordinate is 2. The y-intercept is the point when x is 0. So to find this value, I simply substitute 0 in for y. So we have 2 times 0 minus 2 squared plus 5. While 0 minus 2 is -2, if we square that, we get 4. 2 times 4 is 8, and plus 5 is 13. So the y-intercept is 0, 13. Okay, well, let's find, does this have a max or a min? In other words, does our quadratic look like this or like this? Well, since the leading coefficient 2 is positive, our quadratic is going to open up. So is this a max or a min? Well, this is the bottom. That means it's a minimum. So our minimum is just the vertex, which is 2, 5. Now the fun bit. Let's put it in standard form. Well, this square just means we're multiplying this binomial by itself. So x minus 2 times x minus 2, and we still have this plus 5 on the outside. Okay, well, let's multiply these out. X times x is x squared. X times negative 2 is minus 2x. Negative 2 times x is minus 2x. And negative 2 times negative 2 is plus 4. Don't forget, we still have this 2 on the outside, and we still have this plus 5 on the outside. So now we can combine the like terms. Negative 2x minus 2x is minus 4x. Now we can distribute this 2. So 2 times x squared is 2x squared. 2 times negative 4 is negative 8x. And 2 times 4 is 8. And we still have this plus 5 at the end. So our last step is to combine last terms one more time. So 2x squared minus 8x plus 13. And I'm happy because this is our y-intercept. And that matches our y-intercept up here. Okay? So this is standard form. Okay, so first let's label the x and y intercepts. Well, to find the x-intercept, that's when y is 0. The x-intercept is when y is 0. So if y is 0, that means either x plus 1 equals 0, or x plus 5 equals 0. Because if I multiply these together to equal 0, at least one of these has to be 0. So if x plus 1 equals 0, that means x must equal negative 1. If x plus 5 equals 0, well, that must mean that x equals negative 5. So this has two x-intercepts. To find the y-intercept, we've done that already. That's the point when y, or x rather, is 0. So if x is 0, what is y? Well, it's negative 0 plus 1 times 0 plus 5. Well, 0 plus 1 is 1. Zero plus 5 is 5. 1 times 5 is 5. And negative 1 times 5 is negative 5. So our y-intercept is 0, negative 5. Now we need to find the vertex. To find the vertex, that is the middle between negative 1 and negative 5. If I have a quadratic that looks like this, okay, here is an x-intercept, here is an x-intercept, and the vertex is right in between them. Because remember, it is symmetric. So since the vertex is going to be in between these 2 points, I can just average them to get the x-coordinate. So what's the average of negative 1 and negative 5? Well, I just add the 2 and divide by how many I have. Negative 1 plus negative 5 is negative 6. So the vertex has an x-coordinate of negative 3. Now I need to find the y-coordinate. To find the y-coordinate, I simply plug this value into the function that I'm giving. So I need to find f of negative 3. That's negative 3 plus 1 times negative 3 plus 5. Well, negative 3 plus 1 is negative 2. I have this negative out front. And negative 3 plus 5 is 2. So negative 2 and 2 make negative 4. And I apply this other negative, and I get positive 4. So the vertex here is negative 3, 4. Well, the axis of symmetry is just a vertical line that goes through the vertex. So the axis of symmetry is the line x equals. Well, the x-coordinate of the vertex is negative 3. Okay, I hope all this helped. Thank you for watching.